Boy, I can bring on. Let's go. We're giving candy right when I'm leaving. That's show you this.
Okay. Today we are going to talk about multiplying and dividing radicals. When we are multiplying our radicals, numbers on the inside get multiplied, numbers on the outside get multiplied. Okay. What? I have Starburst. Hey. So when I'm looking at the square root of 5 times 35, since 5 and 35 are both under the radical, I am going to multiply 5 and 35 under the radical. Could the garage.
Oh, say, they're always telling me to do radicals. I never
I remember I did this in the sixth grade.
This is what I mean.
We're doing it. That's how I actually.
Can somebody help me out? What is 5 times 35?
175. 175.
It just like simplifies to get smaller.
Wait, hold on.
So here we go. 175. Is that a number that is divisible by a perfect square?
It's 25 times 7.
Yes.
It should also like be 35 and 2 times 7. They got the square.
Yep.
Okay.
So we have 5 radical 7. Okay. Now this is what Dalton noticed. He came up here and he said, okay, well, if I have 5 times 35, 35 is 5 times 7. So there's my 5 squared that comes out of the radical and the 7 stays underneath.
That works for everyone.
Yeah. Yeah. Well, it makes no sense. I'm giving you 2 different ways you can do this. Okay. Now, look at this problem right here. This one's a little different. Okay.
I know how to do this.
What we're going to do is if there's a number outside of the radical, those get multiplied. If there's numbers inside the radical, those get multiplied. Okay, 56. Is there a perfect square that divides into 56? 8's not a perfect square.
16.
Oh,
Wait, why can't you not? 4.
So 4 times.
12. What? That's
48.
4 13. Or 14. 4 14. 14. Oh, wait.
Good now?
Yeah.
So now the square root of 4 is 2, which then, since it's outside of the radical, can get multiplied with the 6. So are you talking it as in 2?
Yes.
Okay, well, the square root of 4 is 2. It's not the square root of 2. The square root of 4 is 2.
So it's not square root anymore, that's why it leaves the garage.
Yes. And it can only leave the garage if it's a perfect square.
The G.
The Jeep.
That's your G wagon.
It's a Jeep.
Okay,
So far.
since what, 14 is not divisible by a perfect square. Because it's 2 times 7,
Oh, yeah.
okay? Okay, how about you quietly try this one?
Stop. Oh, I thought you were asking if you were. It's 80.
We're quiet. Bryce, what'd you get? We can take 4 times 2 to get 8. 5 times 20 is 100. What's the square root of 100?
Yeah.
Colton, is there an argument happening back there?
I think he's very, he's actually very smart. Thank you.
Well, yes. Okay, so you ignored my explanation?
Yeah.
Can we maybe not do that next time? I like that you're helping him, but if I'm talking. Okay, all right, now. When we divide, we cannot leave a radical in the denominator. So we need to do what's called rationalizing the denominator. A square root that is simplified is what is considered an irrational number. It cannot be in the denominator. Did you just say that I'm irrational?
Oh.
Wow. Colton, thin ice here. Thin ice. Can you wait until after this example? You literally cannot. Okay, I'm waiting. I'm gonna make you take that Starburst.
I think I deserve a Starburst.
I think Tyler
He's
did
going
Starburst.
to get, he's going to get paper.
He learned something new and I taught him.
Okay. The square root of 10 cannot stay in the denominator. Does anybody have any ideas on how we can get rid of it?
Multiply both the top and the bottom by 10. I square root of 10.
Ooh. Now, Colton,
You're smart now.
why is this helpful?
Because then you get rid of the thing on the bottom and
Okay. Okay, so let's fix your vocabulary real quick. So, by thing, I think he means radical.
yeah.
The square root of 10 times the square root of 10 is 10. And the square root of 5 times the square root of 10 is the square root of 50. Now, let's go ahead and talk about why he chose square root of 10 and why we have to do it. Okay? We cannot leave square root of 10 in our denominator. So Colton thought, if I multiply square root of 10 by itself, we no longer have a radical. Well, we can't just multiply the denominator by something. we have to multiply numerator and denominator by the same thing, so it doesn't change the value. If I simplify this right here, what's this number? Multiplying by 1 doesn't change anything. Now, can I leave the square root of 50? No. 50 is 25 times 2. So 5 radical 2 over 10. Is that it? 5 over 10. We have radical 2 over 2. Which equals radical 2 over 2. Divide them by 5. Okay, hold on. We gotta digest this. Hey. Make 5. We can only divide numbers that are outside of the radical with each other. We can only divide numbers inside the radical with each other. So since 5 and 10 are outside of the radical, we can do that division. But here, since this 2 is under the radical, but this 2 is not, there is nothing we can do. Nothing.
I thought 5 divided by 10 was.
Hold on, I'm getting 3 people asking me a question at one time. Emily. Radical in the numerator is perfectly fine. We cannot have a radical in the denominator. Tyler.
I thought, like, so you know how you got 2 on the bottom? The answer?
Yep.
I thought 5 divided by 10 was 1/2.
And what's, okay. So we have 1/2 times the square root of 2.
So it's the square root.
Okay, I would like you to come up with answers for these 3 problems, okay? I do not mind if you and your elbow partner consult each other at a very quiet level, but we're not consulting anybody outside of our table. We aren't yelling across the room. You and your elbow partner can consult each other. What do you need, Jonah?
She just said that.
What'd you say?
Because that is 4 and that is 4 and 20 years. And then 4 is the 2. Like 2, like 20, and then 40. My great got 81. Okay, I actually not do this stuff.
Drew, can you get us calculators?
Yeah, I'm a business.
I'm actually like, I literally just went to
How do you? Oh, I forgot. What's the second step?
I mean, I did too.
What'd you get?
40 and 21.
Oh, I got one.
I think you're wrong. Yeah.
Now you're 2 radical, 2 outside. So 20, it'd be 20 and then 7. And then 80.
I got 21 is the distance. I have
21. Then you find the.
Yeah. What did you get?
I got 0.92.
Wait, yes, it can. Wait, no, I can't. What is? I was thinking about 9, but 9's 26. So I'm dumb. 21 is no, that was only for that.
So you can
You multiply. Yeah. What do you think? You could do 27. Or you add 4.
That's just what that's not what that MJ, you're not gonna be done.
Well, why not?
Because she said.
It's no decimal, Jake.
Oh, that's about
Oh, so it's baloney because you tried to put 4.5 in your square root
You
there,
said.
and I got that, not okay.
You said no decimal.
Okay, wait, Miss Holman, okay, so, because you can look at this, so what's 40? So, for this, it's 42%, so that is, we never.
It's 4 times 20. You have to.
So, you do the square root of.
Oh my gosh. Times 7. So that is the square root of 42 over 7. 6 and 7. Over square.
And then you could do.
Miss Holman, which part do you do first? Do you simplify that together? That part out of the
Actually, that's square root.
Yeah,
That's
that's
what you simplify.
Yeah.
42 over 7.
Square root of 42. 3 over 4 and.
Yeah, that's pretty much, but you can't have that.
True.
It's the square root of 42 over 7.
And square root of 2. Yeah.
Oh my God.
Make 5,
Wait, with the second one, hypercurling well over 1 now.
make 5. Make 5. Is this thing on? Can you hear me?
You're not holding anything.
I have a
You
microphone.
should get a little nice.
Wait, can you use it?
Use
I
it.
don't like Mr. Question.
Bryce, your first step for this first one was what? So 20 square root of 84, okay? After 20 square root of 84, Zach, what did you do? Okay. So since the square root of 4 is 2, this becomes 40 radical 21. Are you okay with that answer?
Yeah.
Aiden, do you agree with this answer? Could you show me where you have it?
I believe him.
I'm ready for you to be quiet.
I wasn't even talking. Back to the you're talking to me.
For number 2, Drew, what's our first step?
And then on both the numerator.
So we have the square root of 42 over 7. Can we reduce that?
No.
Well, that's a nice problem, isn't it?
Yeah, I know. Wait.
Because square root of 7's in the denominator and we can't have a radical in the denominator. Are you okay with this now? Now, I've had some people ask. Yes,
Where do we go from 42 and over 7?
We go nowhere because 42 is not a number that has a factor that's a perfect square. 42 is 6 times 7. I don't know if you have a question or if you're just glaring. Confirmation would be great. Okay, so some people wanted to reduce radical 12 before they went forward. Some people wanted to go straight to getting the radical out of the denominator. It doesn't matter which order you do things in, as long as you just keep simplifying to the end. So how many of you reduced radical 12 very first thing? Not very many, okay? How many of you multiplied by radical 12 right away?
Oh, wait, that's what I did.
So we have 3 radical 12 over 12, okay? There are 2 things that are wrong. Number 1, 3 over 12 is not simplified. Number 2, radical 12 can be simplified, okay? Here again, I don't care what order you do this in, okay? I know that radical 12 is 4 times 3, right? And so I know that the square root of 4 is 2. What's 3 times 2? Okay. So now 6 over 12 can be reduced to 1 over 2.
Yeah, we're 12 divided by 6.
Okay.
Not gonna happen every time. It was a fun coincidence. Okay. I have something that I'm a little bit frustrated with. Yesterday, there were 8 pieces of paper left on my tables. Gold sheets and homework sheets.
Oh my God. Jonah, how you doing?
It's okay. I'm serious.
Oh, you gave us that. You gave us that.
How could we not?
I actually took mine. I threw the red signs.
This is how many pieces of paper were left on my table. Just listen to me, please. This is how many pieces of paper were. You think that I don't know what you and Cohen are talking about right
I
now?
don't get it, I just don't.
Just step out into the hallway. How many pieces of paper were left on the table? I don't know how you treat your mother, but I'm hoping that she doesn't have to pick up after yourself all the time. I do not want to pick up after you. When I give you something, it's because I think you need it. And if you don't think you need it, then recycle it or throw it away, but don't leave it for me to clean up after. I am going to give you your homework assignment. My expectation is that it remains quiet in here. I don't mind you working with your elbow partner, but I need you to be working on the math. And this time, I only printed on the front because there's only a front.
I got like a 47.
I don't want the homework.
I think I gave somebody an extra one.
Oh,